Hey everyone.
Good evening. Thanks for sticking around until the end of the day.
Yeah, we're gonna have a casual but very interesting fireside chat here. First, Matt, why don't you introduce yourself and Blocknative and what's the latest?
Sure. So I'm Matt. I'm founder and CEO of Blocknative. We've been building in the Ethereum ecosystem for nearly 7 years now. So we've been there since the very beginning. We're largely known for all of our work in the gas market. So we provide some of the most widely used and integrated gas price estimation and prediction infrastructure. And we're now putting that all on chain. So we're at an exciting moment. But we've been a block builder. We've been a relay. We've done work in the public mempool. We've done a lot of publishing on research. We've helped figure out major hacks and things like that. So we have a lot of war stories to tell.
I hope everybody here is mostly aware of Blocknative, but for those who aren't, I was also part of the Blocknative journey. We were there when MEV got started and became a thing, and that also ended up forming how I founded Primev. So at Primev, we've essentially once Blocknative started becoming a block builder during the merge in Ethereum. And I was there and I was encountering a lot of problems people were facing. Essentially, people wanted guarantees from block builders. And this eventually turned into an idea of a network that could provide these guarantees from block builders, which eventually turned into Primev today. And we've created this network called MEV Commit that allows block builders and other Ethereum actors to issue these real-time cryptoeconomic guarantees in the form of cryptographic commitments. So that's a whole bunch of jargon, but essentially today we use that for pre-confirmations on Ethereum to make Ethereum fast. It's soon going to be as fast as Solana, if not faster in many ways, with better guarantees. And that's very exciting. So that's what we've been building, and would love to hear what Matt has been up to since my time there as well.
Well, so I think one of the things that's super interesting about the Ethereum ecosystem is it moves super quickly. The foundational elements are constantly evolving, and you don't need to look any further than, I don't know, EIP 1559 or the merge and proof of stake or EIP 4844 and blobs. And we're on the cusp of kind of one of the next ones right now, which is pre-confirmations, which are going live. And there's a whole bunch more that's being planned as part of Pectra. We at Blocknative really anticipate the chain abstracted and account abstracted future. And as we think ahead to this world, you're basically going to have a multitude of routes to complete any on-chain action, and the users are going to be somewhat insulated from them using things like account abstraction. And the challenge is there's sort of three guarantees in life. There is death, taxes, and Web3 transaction fees. And so as you think through, that world, like you have all these possibilities, you need to know price of each route. And it turns out it's kind of one of these like plumbing kind of problems. Like it's sort of underneath the covers, but it's kind of an interesting and important problem. And it's also an interesting problem that the gas markets that undergird all of Web3 are weirdly largely off-chain. And so smart contracts aren't aware of the gas price on their own chain, and they're certainly not aware of the gas price on other chains. And so we have a new initiative at Blocknative. It's called the Gas Network. It's in DevNet right now. It's at gas.network if you're interested to check it out. But basically, we're trying to move all of the data surrounding Web3 gas markets on chain so that they can be composable, permissionless, and trustless to smart contracts. So for anyone doing chain abstraction, for anyone doing bridging, for anyone doing cross-chain intents and things like that, we think this is sort of a necessary building block. And it's interesting, I ask folks the question, how much do you think is spent on Web3 fees in the past 12 months? I
How much?
actually figured that this is something that someone else would have done, and we could just Google it and figure it out. And it turns out it's not out there. And believe it or not, the real number is $5.2 billion spent in the past 12 months on Web3 fees across chains. And
That's a
so it's a
lot.
huge market, and it's really disorganized and really inefficient, and we're trying to bring it all on chain. That's what we've been up to.
That's super cool. And for those of you who are maybe not so aware, Blocknative was the first one to create a new kind of gas understanding. Gas before Blocknative was essentially this fast, slow, medium kind of understanding, and Blocknative came up with a statistical model about inclusion related to gas. Matt, do you want to tell us a little bit about that?
Sure. It's funny I sort of glance over that. It's so long ago, but there's this idea that you have this time, right? Like I'm going to do it slow, medium, or fast. It turns out that it's not really how it works at all. It's just kind of a construct for users. And really, the big factor of Web3 transactions is inclusion. And your price determines your probability of inclusion in the next block. And so the innovation that our team brought was rather than just give three kind of approximate numbers, we actually build real-time statistical and ML models that will predict the probability of inclusion at different confidence intervals. So our APIs and the oracles that we're putting on chain will return 99%, 95%, 90%, 80, and 70. And the basic idea is, if you were to take our 99% figure and use that to price your transaction, you'll be included in the next block 99 out of 100 times. That's the goal. So the challenge with gas prices is they're moving constantly. And so it's sort of a Goldilocks problem where you want to be high enough that you're included, but not so high that you're wasting value. And the bigger risk is actually being short, because if you're just a little short, you don't get included, you get worse performance. But then on top of that, we actually build a bunch of modeling where we can predict these confidence intervals into the future. So on Ethereum L1 today, we predict 5 blocks into the future. And so you're able to see if gas prices are rising or falling, which basically can tell you, oh, gas prices are going up. You better transact right now, because if you wait, it's going to be more expensive. Or gas prices are going down. If you can, chill out for a little bit and you'll pay less. And it turns out over a very large number of transactions, these sorts of probabilities can add up to a fair amount of value, both value in the form of not having issues with stuck or drop transactions or delayed transactions, and not overspending. For high-speed chains, for other chains, not Ethereum L1, you have to predict further into the future, because if I tell you the gas price right now, 250 milliseconds, there's now a new block. And so we actually are doing longer and longer gas prediction. And the sort of core of all of this, of course, is let's make this gas issue as simple and easy to work with as possible. We'll do the deep nerd stuff so that everybody else can just focus on building on top of it. Amazing. And what chains does that work on today? Oh, good question. Ethereum L1 is our core, but we support Polygon, Base, OP Mainnet, Arbitrum, and coming soon, though not out yet, will be Blast, Linea, ZK Sync Era, Phantom, Say we support today, and a bunch of others. So we're trying to move. We're about on a dozen chains today. We'll do a whole bunch more, and we just think it's really critical to all of this. And it's actually kind of an interesting input to the world of pre-confirmations. So what happens on pricing and pre-confirmations?
Great question. So it depends on how you're thinking about pre-confirmations. In our case, MEV commit hooks directly into block builders. So each block builder has a different view of their own mempool, and therefore they will have a different price. So what you really want as someone who's trying to receive a pre-confirmation is you want to bid a high enough price where all block builders will find that marketable, right? So they will basically all say yes to the price that you're bidding, so that you're not kind of bidding individual prices to any of them. And how that really translates into an experience is, you might bid something like, let's say you bid X or 10, and after you bid 10, either everybody accepts it or maybe one person doesn't. And then you know a little bit more information about the market. Oh, this guy knows something that I do not, because he's not accepting 10. So that now I'm going to bid 11, and maybe 11 he'll accept it. And yeah, it turns out he accepts it. So somehow he had some other information that these other block builders didn't, and therefore he priced it at 11, whereas the others priced it at 10. And you engage in this price discovery in real time to get this pre-confirmation. But it's beyond just gas, because gas has still its own function and its own use. What you're getting with this cryptographic commitment is also this economic guarantee, where if the transaction doesn't go on chain, you get some money back. And that's fundamentally where the narrative shifts a little bit from gas alone. And so on the topic is MEV design space.
how does this intersect with MEV?
Well, gas determines whether MEV happens or gets extracted at a certain point or is optimized and is included. So at the end of the day, gas and MEV go hand in hand, kind of like oxygen and water. And how you price gas in turn creates or disallows MEV to be extracted. But I'm curious how you guys are taking gas on chain. Can you tell me a little bit about that?
So it's a good question. We've developed a fairly specific Oracle network. So what winds up happening is if you have a smart contract, let's say on Arbitrum 1, and it needs to be aware of the price of, let's say, ETH L1, that Oracle has to be available on Arbitrum 1 because the smart contract doesn't want to do cross-chain communication because it's expensive and slow and has security implications. So what you wind up doing is building, or what we're building, is what's known as a vertical Oracle network. So it's basically a high-speed Oracle network with local oracles on each of the target chains powered by an underlying app chain. And so we have a high-speed app chain that then uses cross-chain messaging to communicate with the oracles. And so basically you wind up in a many-to-many scenario. By the way, for those of you who stuck around, I'll give you a good nerd snipe, which is called the Nyquist frequency, Nyquist. It's a signals processing thing. And so imagine you have a signal, and then you only sample it every so often. And if you don't sample it frequently enough, you actually miss the signal. It looks like a straight line. And so the Nyquist rate is the minimum rate that you can sample any signal to get price. And so what we have to do is run a very high-speed app chain to make sure we're tracking the gas prices, and then make those available on the target chain via a distributed Oracle network. So it's a kind of a unique architecture. It's somewhat similar to what the Pith network's doing, and it works really, really well. And if anyone's building and has use for this sort of stuff, please let me know.
And where can I learn more about this?
This is gas.network. You can check it out. And by the way, we haven't really announced it yet. It's just something we're talking about here. So you guys are getting advanced access to that as well.
The latest alpha on gas, everyone. Thank you for joining us.
There you go. Thanks, everyone, for sticking around. Thanks, IOSG, for hosting. It's a pleasure to be here. And have a great rest of your evening.
Much appreciated.
Thank you, Matt and Murat. Thank you. And we can take a group photo after this.
Thank you so much, guys, for coming. Here's the last session of the day. So later on, we will have a group photo session. So if you can stay here and can come to the stage to take a picture with us, that would be a really pleasure.